Assalamualaikum. Today, we from Group 7, we want to present about flood mitigation. Here are my team members. First, Muhammad Aziz bin Ana. Second, Muhammad Arshad bin Bakhtiar. Third, Nur Shazwani Atirah binti Nur Asman. And fourth, Nur Shahidah binti Muhammad Yusuf. And lastly, Muhammad Ashraf bin Mustafa Kamal. Okay, for introduction, in this era, things that always in demand are flash flooding. As we know that many cases happen nowadays are related to flash flooding. Flash flooding is a particular kind of flooding that happen quickly after a precipitation event. Usually within 6 hours, it's usually happen in area near river or lake and is brought on by heavy or extensive rainfall. Though it can also occur in area without any nearby water bodies. Okay, we go to the study area. The study area is located at Jalan Keluang, Taman University, Parit Raja, Johor. Parit Raja, Johor is a mukim located in the district of Batu Pahat, which is a lowland region. Agriculture is one of the region's main economic sector thanks to the location of this lowland topography. Batu Pahat district is susceptible for flooding because of its low elevation. In this area, the current drainage system plays a significant role in causing flooding. Okay, for the objective, we propose a suitable drainage system that could effectively reduce the heavy flow. Second, determine the ideal size and type of drainage system for Taman University Parit Raja. And lastly, analyze how the water moves through the drain along the Taman University Parit Raja proposed drainage. For the problem statement, the drainage system was not properly planned to prevent flood and heavy rain from overflowing into the road. And lastly, the size of the flow channel must be carefully considered when designing the stormwater drainage system because it is inappropriate for the area. Stormwater drainage. The drain was determined to be a natural open channel drainage system based on the research area. There was grass, sediment, and mud along the existing drain. The water flow will be impacted by this limitation. As a result, it is recommended that the drainage be upgraded into a structural type of drainage by building a new drainage system using an U-shaped reinforced concrete drainage.
Assalamualaikum. My name is Nur Shahidah binti Muhammad Yusuf. My match number CF220219. So today we continue this presentation with methodology. So the aim for this project was to hand complete the drainage plan in the part of Jalan Keluang Taman University Parit Raja Johor to correctly suggest a drainage plan that works. The area, climate and condition were designed using appropriate analysis process. According to the report, the region was vulnerable to flooding brought on by flash flood, which happened during brief but powerful downpour. So I will continue for the first step, which is we calculate the area of catchment. So the area was surveyed by our team member to study and collect all information that can be obtained in the area. The area of a catchment was also calculated by using Google Earth on the website to get the area and dimension of the desired area. The total of water washed is 243,916.82 millimeter. per square and perimeter is 2.05 km. The rational method was used to properly calculate the data analysis. The Urban Stormwater Management Manually for Malaysia was used to identify the peak discharge, which is Q for the area. So the second step is calculating the manning roughness, which is N. Data from the table must be obtained before we can begin the calculation. Our team comes to the conclusion during the site survey that the area was a grass drain with a tall grass cover more than 150 millimeter. So the N is 0.050 is the manning roughness. Table beside show that serve as the sources for the second table. So the third step is calculating dimension and area of the drainage. According to the information provided by our team members, the drainage design was a trapezoidal drainage with a surface area of 7.25 km and the perimeter drainage was 7.35 meter. The drainage R was computed using all the data from the trapezoidal drainage and the answer was 0.97 meter.
Okay, for the next step, I will continue with the friction slope. The formula for friction slope is highest elevation minus by lower elevation divided by length of the channel. The length of the channel that we get here from Google Earth is 702.27 meter. So the highest value of elevation that is 10 and the lowest elevation is 8. By using the formula of the friction slope that we got here is 0.0028. Okay, continue for the next step. We are calculating the empirical IDF curve, which is there is two component of the formula that we need to calculate, which is the average recurrence interval and the storm duration. After that, we continue using the formula, using the data that we refer from MASMA for store daerah JPS Batu Pahat. After inserting all the data such as average rainfall intensity, average recurrence interval, storm duration and others, we get the empirical IDF curve is 633.23 mm per hour. After we get the value of the IDF curve, we continue with the last step, which is to calculate the peak flow. We use it in the formula as stated in the slide. For the run-off coefficient, we refer to the table. And as for this area is for commercial and business center, and the design is for over 10 years. Using the coefficient is of 0.95 times by the IDF curve that we calculate just now, times by the area and divide by 360. So the peak flow that we count here is 11.91 millimeter square per second.
Hi, Assalamualaikum. My name is Muhammad Ashraf bin Mustafa Kamal. Now I will present about trapezoidal channel section of the drainage. Okay, first let me explain about calculate area. To find area, B times Y plus Z Y power of 2, and we get 7.125 m cube meter. Okay, to find perimeter, P is P plus 2y square root 1 plus Z power of 2, and we get 7.35 meter. And for R, A power of A divided by P, and we get 0.97. And next, refer equation 2.1. For S, we get 0.0028. Okay, for the next slide, refer table 2.1. TD equal to N times L over 60 times R power of 2 over 3 times S power of 1 over 2, and we get 11.29. Grass drain, tall grass cover more dense 150 millimeter. And next, refer table 2.4, states Johor, station ID 1829002, and station name set to daerah JPS Batu Pahat. For the lambda, we get 62.1576. For K, we get 0.3055, and for theta, we get 0.1423, and last N, we get 0.8253. And next, table 2.5, type of developments, commercial and business minimum, ARI, years is 100, T equal to 100. For next, refer equation 2.2, I equal to 633.23 millimeter hour. Okay, for the next, runoff coefficient and peak flow, refer table 2.6, then use commercial and business runoff coefficients 0.95 more than 10 year ARI, C equal to 0.95. And next, refer equation 2.3, Q peak is 11.91 meter cube.
Okay, next we move to the proposed new design of channel section. Our group proposed that the bottom width of the new design is 6 meters and the depth of the channel is 3 meters. First, we calculate the area of the channel section. For the area, the area will get is 80 meters square. For the weighted perimeter, the value we get is 12 meters, and for the hydraulic radius is 1.5 meters. For the friction slope, the value is still the same, 0.0028. For the drain flow, for the new design of channel section is 8.44. For the rainfall intensity is 660.42 millimeter per hour. And finally, for the peak flow for the new design is 31.37 meter cube per second.
Okay, the next slide is proposed flood mitigation. A good drainage system is essential for preventing floods in the study area. To address the issue of inadequate drainage in flood-prone area, it is recommended to modify the existing drain. Without proper drain, water accumulates and causes flooding. Improving the drain by increase its capacity will minimize damage to properties and reduce health risks and potential fatalities in the future. The proposed drain will be built in the same location as the previous one, but with a U-shaped design made a reinforced concrete using cement, aggregate stones, steel bar, and sand. Excavation, sand placement, drain installations, compression, and connection are necessary for the construction, which requires the use of an excavator. The use of material like cement ensures smooth water flow with less resistance compared to grass. The drain's slope flatness are carefully calculated and constructed to effectively drain water even during heavy rainfall. The drain construction aims to prevent future floods and also provide safe route conditions for residents and students and bus stop users during after rains.
Next, for discussion, after performing the previous calculation, we discovered that the suggested new design for the channel section passed because the flow design of the discharge was found to be higher than the flow peak of the discharge. In addition, as indicated in the table, we discovered that the flow rate of each drainage size varies depending on the length and depth of the channel. So the table is show that comparison between old and the new design drainage size before and after. So the Google Earth is a computer program that create a 3D depiction of the Earth mostly using satellite imagery. Undoubtedly is the most well-known and commonly used geographic information system. In addition, this program offers terrain flight simulator and tools for measuring distance. Thus, in this project, the cross-sectional of the drainage area is measured using a logical way to determine the value of discharge. For this method, we discovered that the cross-sectional area is 5.42 hectare, which satisfies the proposed area criterion that the area be less than 200 acre. Then, the type of grass drained with long grass cover more than 150 mm determined with the value of n as 0.050 based on the value of the meaning roughness coefficient is one of the most significant parameter in hydrological calculation that represent the loss energy in open channel and is frequently used to calculate the discharge and fluid water elevation. The hydraulic mean radius can be calculated after determining the meaning roughness coefficient and the result is 1.5 meter. The drainage friction slope must be calculated and the result is 0.0028 meter. As a result, many equations hold true of constant water flow rate through a channel with a constant size, shape and roughness of the slope. In addition, we choose to increase the drainage depth and line in order to prevent flash flood during the rainy season, when it rains, water flow effortlessly and there's little chance of clogging.
Okay, conclusion. In summary, there are a number of civil engineering projects that require hydrological study to be successful. Hydraulic is a broad field that is essential to society, particularly in civil engineering, to develop infrastructure for water resources so that adverse environmental effects are minimal. One of the fundamental responsibilities of the design and engineering team is to make sure that there are no drainage problems on the job site, particularly with regard to how structural work will be impacted by uncoordinated weather or other conditions that could result in flooding from out of the drainage. Thank you for lending your ears.